Hey everyone, so here we are with 7.3 as we're starting to get into the operations with these rational expressions. Multiplying and dividing is this lesson. Actually, we're going to look at simplifying rational expressions first, just to get to be familiar how to simplify just a rational expression, and then we'll multiply and divide. So let's go ahead and first look at a cartoon, a little in the bleachers. So here's a coach saying, "Take the field. Remember, your parents are counting on you to achieve their unfulfilled dreams of sports glory." I love this guy right here. He's like, ah! Alright, so let's go ahead and start on our simplifying rational expressions. So page 202 in your notes. So first of all, there's a couple of vocabulary words to put down. Rational expression is the first one, and you can just write down that that is a fraction. So when you think of rational expression, it is a fraction with polynomials, and that's what you can kind of say, a fraction with polynomials on that one. So the domain of a rational expression excludes values that make the denominator 0. So as far as like what is the domain of certain things, I mean, we know fractions cannot have the denominator equal 0. So that means just x cannot be making the denominator 0. So remember, the domain is about our x values. So x is excluded here, or exclusive to only numbers that will make the denominator a non-zero number. A rational expression is in simplified form. So simplified form there, you can put that, for that one you want to put down, it's when the numerator and denominator have no common factors. Obviously other than 1 or -1. But there's no common factors with the numerator and denominator. So we have a core concept here. You can kind of just see how we're doing this. Here's one example with just some numbers. That's just simplifying, knowing we can simplify by 5 down and get to 3/13. Here's one with expressions. We can cross out matching binomials. So an x plus 3 can cancel out with 1x plus 3 on the bottom. So we always want to make sure, if we have any polynomials, that they're all in factored form, so we can see the prime factors of this, and then we can cancel out the matching prime factors, and then whatever's left over is just our answer. Okay, so here on page 204 now, in your extra practice, we're going to simplify the expression. It says if possible. I mean, it could be possible that it's already reduced, but these are all needing to be simplified. So the first one we see, what we need to do with these 1 through 4 is just make sure that everything is in its prime factored form. So obviously if you have a monomial, there's nothing we can do with that to factor it, but if you have more than one term, like a binomial or even like down here, a trinomial, we want to factor these and get them into our prime factored form. So we're going to look at this first one as we see that it has two things here. Remember, when we're factoring, we're looking first for, the first step is to look for common factors that we can pull out. And this one definitely has some common factors. 2 can go into 2 and 8. So we're going to pull out that. So we're going to pull out a 2. So we can say 2 is coming out of this, and there's also 2 x's that are going to come out. So 2x squared can come out of this. What would be left now from this first term would just be an x. And so now we can say minus, what's left from this term, 8 divided by 2 is a 4, and there's no more x's, so it's just x minus 4, and this is all over the 6x squared. So now we have a monomial on the outside here with 2x squared and a monomial down here. So monomials can cancel each other out. You can cancel monomials with monomials. You cannot cancel anything that's a binomial unless it has a matching binomial. So as we look at this here, we're going to cancel out the 2 and 6. So 2 becomes a 1, and 2 goes into 6 3 times. That becomes a 3. The x squareds can cancel each other out. So those x squareds will cancel each other out completely. So that just leaves us now with 1 times this x minus 4 on top, and we also have 3. So we're going to write that down for our answer. So our answer is going to be that, x minus 4 over 3. But here's where we have to include what x cannot be. And really it's not from the answer, it's from the problem. So right now there's nothing that x can't be from our answer because the 3 is on the bottom. There's no x on the bottom. But back in our problem, we saw that x couldn't be 0 here, otherwise it makes this into an undefined fraction. So that's why we have to say this, x cannot equal 0 because of back over here. So we do need to talk about or or write down what our excluded values for x is going to be in this problem. Okay, number 2, we'll look at the same idea. We want to factor out any common factors. There's nothing between numbers 5 and 2, but we do have some x's in common, so we can factor out an x, just one x. This has only one x to give, so we can factor out an x. Let me get rid of that. Try again. And then also some y's. We can factor out two y's. There's 2 here. This one has 3, so we have a y squared that also can come out. And so what's left now will be our 5 from this first one. The x is now taken out, and 2 of the y's is gone, so we have 1 y left. Over here, there 2 is still here. 1 x is still left. Both y's have been taken out. And so that's all over our monomial on the bottom. This is a monomial, even though there's 2 variables. There's no plus or minus symbols, so it's still a monomial. So monomial and monomials can cancel out. I can't do anything with this binomial now because there's not a matching one to cancel with it. So as far as x's, I can cancel this x out completely, and this x here will be, this x squared here will become an x. And then xy, or y squared and y squared here will cancel out completely as well. So now what I have on the top is our binomial. What's on the bottom is just the x. So that's what we're going to say for the answer. So we're going to say, that's our answer right there. Now we can see from the problem that x can't be 0. But what else cannot x be? So you got to go back over here. You also have to say, well, since we have a y at the bottom, the variable y can't be 0 either. So we have to include that in our answer. See, right here we can see, well, we definitely know obviously x can't be 0, but what we don't see from the answer is that y can't be 0 either. So that's why you got to include that part. Okay, coming down to number 3, we're going to factor this. This is going to factor these trinomials. Always factor to 2 binomials, remember, and they will be factored with a simple method. It just starts off with x squared. So you always want to see, factor these. You're going to be doing a lot of factoring in this lesson. So the x's, so you got x and x here, and then 4, 2 numbers that multiply to give you 4 that add to give you 5 would be 4 and 1. So we can put a 4 and a 1 because they'll add to give you 5. They're both the same. They're both negatives. So x minus 4, x minus 1. And then down below here, let's put our 2 binomials. And so this one here is going to become x and x again. The 2 numbers for 1 is just 1 times 1 is 1, and 1 plus 1 is 2, so that works out. They're both the same sign. They're both negative signs. So both x minus 1s. And so now we want to see, we only have binomials, and we can cancel out any matching binomials. So I have an x minus 1 up on top that I can cancel with one of the x minus 1s down at the bottom. So my answer still has an x minus 4 on the top and an x minus 1 on the bottom. That's what I want to say for my answer. So it's x minus 4 over x minus 1. Now, since we can obviously see that x cannot be 1, otherwise that makes that a 0, we don't have to say that if it's in the answer. If we go back to the problem, there's nothing else that x can't be. This one that we canceled out was also 1, so we don't need to say anything on this one as far as what x can't be, because we already see it from the answer. Okay, number 4. We're going to factor out on the top here. We're looking to see that we have some common factors with the x squareds. So we have an x squared here, x to the third. I can factor out an x squared. In fact, maybe we'll do that one just for space-wise. Let's put it down here. So I'm going to come down here. I'll say it equals x squared. And then what's left will be 1x plus the 3. Okay, because the x squared's been taken out for that second term. And then below that, we're going to do 2 binomials for factoring the trinomial. Again, just simple method with it starting with x squared, so x times x. 2 numbers that multiply to give me 24. Didn't really want to circle that. But 2 numbers that multiply to give me 24 here that subtract to give me a 5. So we can think, well, 8 times 3, there's 4 times 6, but that doesn't subtract to give you 5. 8 minus 3, and 8 times 3 is 24. 8 minus 3 is 5. There are different signs. The bigger one's negative, so 8's negative, 3 is positive. And so now what we're going to cancel out is any monomials. We do have a monomial here, but there's no monomials on the bottom down here to cancel this x squared out. So I can't do anything with that. But the matching binomial with x plus 3 I can cancel out. So those matching x plus 3 binomials cancel out. So what's left is x squared on the top and x minus 8 on the bottom. That's what we want to say for our answer. x squared over x minus 8. Now we can see from this answer that x cannot equal 8. So I don't need to say that, but what I can't see here from the answer is that x cannot equal a negative 3, because down here we cancel this one out. And from this binomial, x also cannot equal negative 3. So you have to include that one particularly there because it's not shown in the answer. All right, let's keep moving on. Now we're going to go into multiplying. So on page 203, you can see this core concept just showing multiplying. Now remember, from multiplying, we just have to multiply across the top and across the bottom. That's basically the property there. That's the technique. Just to, multiply across the top, across the bottom. So that's they're showing this one here. You're going to multiply these two together to get 30x to the third y. Multiply this together to get 20x y to the third. But like I said here, we would want to reduce this because this is not reduced. So after you multiply, you do need to reduce, and that's where we're going back to what we just did on those 4 problems just a minute ago of simplifying the rational expression. And we would simplify that down, as you can see here, to this now fraction, where we also include anything here, like it says right here from the fraction. We don't see anything that x can't be from the answer, but we do see that x can't be 0, y can't be 0 back from here in the problem. All right, so go on to your extra practice again. So here on page 204, back to the extra practice, we're just going to do the multiplying ones first, and then we'll do the dividing ones. So the multiplying ones are number 5, number 8, and number 9. Those are all the multiplying ones, where we just do the technique of multiplying across the top and across the bottom, and then reducing after that. So starting with this first one, we want to multiply this across the top here. Let me go blue again. So across the top, we're going to see that we have a 3xy times a y. Well, the y's can multiply to get y squared, so this will be a 3x y squared now on the top. And down here, that's 2 times a 1 basically, so it's going to be 2 there. The x's will become x squared, and we have a y squared. So now we want to just reduce this here. So as far as 3 over 2, I can't reduce those numbers, but I can reduce some x's here. I can cancel this x out completely, and this x squared cancels out, and now it's just an x, so I still have a 2x here. The y squareds cancel out both of them completely, and so now we just have a 3 over a 2x. There's my answer, 3 over 2x. Now we can see from the answer that x is not going to be 0. We don't have to say that, but we also need to say that y can't be 0 either, because that was a part of the problem. And so down here when we see the answer, we're going to see the 3 over the 2x, but we also have to include this little piece here with y can't equal 0, because back in the problem, y couldn't equal 0 there. So we don't need to say x doesn't equal 0, because we can see that from the answer. It's x is still at the denominator in the answer. Okay, for number 8, this one now becomes a little more challenging, takes a little more time because we have to do more factoring on this. So we're going to have to factor each numerator and each denominator first to get all these into their prime factors before we can actually cancel things out. So actually in this case, I'm not going to multiply across the top and across the bottom first. Remember, there's another way we can do it. We can reduce first and then multiply. So on this one, I multiplied first, then reduced. But on this particular one, number 8, I'm going to reduce it first, which means cross-cancel, and then multiply across the top and across the bottom. But before I can even reduce, I have to get everything in my factored form. So our simple method factoring on this trinomial right here, let's start with that one. So I'm going to start with the little fraction bar. So let's go blue again. Fraction bar here, all the way across for this one, times this other fraction bar here. So the numerator of this now is going to become 2 binomials. And they start off with the x's. 2 numbers that multiply to give me 3, that subtract to give me a 2 would just be 3 and 1, or 1 and 3. And there are different signs. The bigger one is negative, so 3 is going to be negative, it means 1's positive. And then below this, we would want to see that, oops, let's see here, I need to, hold on. Okay, so now below this we see an x squared minus 1, which that there is a difference of squares right here. So a difference of squares always will factor to 2 binomials. And again, it's going to start off with x's, but then it is just, 1 times 1 is 1, so they're both 1's there. And with a difference of squares, the signs are just different signs. One's a plus and one's a minus. That's how we factor the difference of squares. And here on this one we're going to see two trinomials. They're both simple method, so they'll factor the same kind of way. So they're going to both start with x's. Two numbers that multiply to give me 63, that subtract to give me a 2. Well, that'll be 9 and 7. 9 times 7 is 63, and they subtract to give you 2. They're different signs. The bigger one is negative, which means 9 is negative and 7 is positive. And then below that, another two binomials. Again, they start off with x's. The two numbers that multiply to give you 21, that subtract to give you a 4. 7 and 3. 7 and 3 multiply to give you 21. They also subtract to give us 4. They are different signs. The bigger one is going to be positive, so 7's positive this time, and 3 will be negative. So now that I have everything here in factored form, I can now cross-cancel with matching binomials. So I'm looking for any matching binomials. So right now I see an x minus 3 and this x minus 3. I can cross those out, whether they're on the same fraction or on different fractions, just one on top with one on the bottom. And then we can see I see an x plus 7 here on the same fraction. This x plus 7 and that x plus 7 can cross-cancel. I also see over here, right, one on top of the other, x plus 1 with this x plus 1. So that leaves us now with the x minus 9 over x minus 1. You can see already in it revealing the answer there. X minus 9 over x minus 1. That is my answer. But then notice I have all this other stuff here going on behind it, what x can't be. I can see from the answer that x can't be 1. So that's the only one I don't have to list. I don't have to list x cannot equal 1. But I do have to list all these other ones here that I canceled out. So I canceled this one out where x can't equal negative 1. So that's got to be a part of my list. This one with x plus 7, x can't equal negative 7. That will be part of it because that would make that a 0. X can't be positive 3 here. So there's that one right there because I canceled that one out. So you got to make sure you list all the ones that x can't be that are not apparent from the answer. That would go back into your problem and see, oh, x can't be these other numbers because they're in the answer. They're in denominators over here. All right, so number 9, let's go ahead and factor each one of these. We're going to do the same kind of thing. Factor each one. So I'm going to factor the numerator. This denominator is already factored here. So right here we have I'm going to factor out an x. That's all it needs to happen here. So we're going to see an x coming out of this first one. And then what's left is an x minus 2 binomial. That's over this x plus 7. There's nothing to factor for that one. And we'll say times. And now this next fraction. Now this right here, we need to remember this is called a sum of cubes. A sum of cubes here. This is a sum of cubes where it's got x to the third plus 8. It's a binomial, a special binomial called a sum of cubes. And so that has a special way of factoring, remember, as we did that back in chapter 4. It's always going to factor to a binomial times a trinomial, where we start with the binomial. So basically from this one, it starts out with x to the third, so we're going to start with x here. So basically, what do you need to multiply by itself 3 times to get to x to the third? Well, it would be x. What number do we need to multiply by itself 3 times to get an 8? Well, that would be 2. 2 to the third power is 8. The sign is always going to be the same inside that. So there's an x plus 2 binomial there. Now for the trinomial, this first one, the trinomial, is this x times itself. So x times x is x squared. The last one in the trinomial is the 2 times itself. 2 times 2 would be 4. And for the middle term, it's just these two times each other. That's going to be 2x. Right there in the middle. And as far as the signs go, the first sign is always opposite of what this one is. So since this is positive, our first sign here is negative. The last sign is always positive no matter what. So that's how that one always factors. And then down below this, we just need to factor out one x. That's it. Just factor out an x. We're going to be left with an x squared minus 4. But now from this, I need to recognize that this is a difference of squares right here. So that right there is a difference of squares, and we need to factor this again. So actually this will factor to 2 more binomials. You need to recognize this, where we start with x and x from the x squared. 2 times 2 is 4, so it's the 2's, and then 1's plus and 1's minus. So we need to recognize that's the prime factorization of this difference of squares. Just like we did up here with x squared minus 1, we got those two. X squared minus 4, we get these two. Okay, so now we're going to go ahead and see what we can cross cancel. So first of all, I see I have a monomial x here and a monomial x there, so I can cancel those monomial x's out. Monomials can cross out with monomials. The binomials, so I have an x minus 2 here. I do have an x minus 2 now down here. Remember, this now is this. So maybe we want to not look at this anymore here and just look at these two. So we have x minus 2 now crosses out with this x minus 2. This x plus 2 crosses out with this x plus 2. So that whole thing is gone down below this one. And now what's left is this trinomial over that x plus 7 binomial. That's going to be our answer. But we have to include anything that we crossed out. So what variables did we cross out? We didn't cross this one out, so we don't have to say anything about the 7. But we did cross out an x here, so which means x can't be 0 here. So we got to say 0. We got to say positive 2 and negative 2 as well. So those are the three that we do have to include here. So there's my answer, the trinomial over x plus 7. And then these three numbers, x cannot equal 0, 2, and negative 2 from the ones we crossed out with the variables in them. Alright, so our next part now would be to do the other three problems that are division. So let's look at the core concept for division. But first, before we do that, let's do a little joke of the day. What does a nosy pepper do? Well, it gets jalapeno business. I love that one. Okay, so now on to dividing. As you can see, we have an example here with some rational expressions, and we got the fraction divided by another fraction. We got some rational expressions in there. So the same will apply. We're just dividing fractions. We got to multiply by the reciprocal, so they're going to change this division to multiply, and they flip the second one upside down, as you can see. That's always just the property of that. Is what the property says here. When you're dividing fractions, you're going to multiply by the reciprocal, c over d. Reciprocal would be d over c. And then you multiply across the top and across the bottom, or you could cross cancel and then multiply. It says simplify if possible. Of course, we'll do that. So that's what we're working on here, is we're trying to get this in the simplest form as possible. Alright, so let's go ahead and try a few on our extra practice. So actually first I wanted to show you this one because this one's so far we've seen a bunch of factoring problems, but we haven't really seen anything where we had to use the star method, and so I wanted to show you this one again so we can see how we would do the star method one more time. So we would find the quotient here, it's division, we would flip this upside, this is like over 1, so you could see kind of how we're doing this. So you could put this over 1, so now the reciprocal of this would be 1 over that binomial, and then they would need to factor this. That would be the next step, would be now to factor this trinomial here, basically factor out an x on the bottom of this one as well. And so I just wanted to have you do this. So down below on the bottom of 203, just write down this trinomial, 6x squared plus x minus 15. And let's go ahead and just factor this. So we would do our star, you draw your x and then a line across the top. And so the top number of the star is always your first number times your last number. So 6 times negative 15 gives us negative 90. And then the bottom part is just always the middle, the b number right here. So this middle one is plus 1. So it's a positive 1 down at the bottom. At the top of each side, we're always going to put the way it starts. It starts off with a 6x. So we're going to put 6x on the top of each side. And now for below that, here's where we ask ourselves that question, what two numbers would multiply to give us 90? That would subtract to give us a 1, and that would be 10 and 9, where they're different signs, but the bigger one is positive, so it's positive 10 and negative 9. And then we would see we have a 6x over negative 9, and we can reduce that. So we want to reduce the 6x by 3 here. So this becomes a 2x here, and then 9 becomes a 3, a negative 3. And then that means over here, we're going to reduce this 6 and 10 here by 2. So the 6x becomes 3x, and the 10 becomes a 5. And so that's our binomials now. 2x minus 3 is one binomial, and 3x plus 5 is the other binomial. And now that's factored, and that's what we would need to see over here. That's how they're getting this now. The 3x plus 5 binomial, 2x minus 3. They factored that one x out there as well. And now they're ready to go ahead and just cross out the 3x plus 5 binomials, continue to multiply across the top. Alright, so I wanted you to make sure you wrote that one down so you could see one that was done with a star method, so you remember how to do that star method when you actually do some of your own problems on the Big Ideas assignment. Okay, so now for our last few problems here on page 204, we're going to be doing the division ones, which are 6, 7, and 10. So for 6, we're going to first just change division to multiply, and then work on multiplying. So we're going to keep this first one the same. So I'll keep this first one the same. We have the 7 over 7xy. And now I'm going to change division here to multiply, and I'm going to flip now the second one here. So it's the reciprocal of the second one. Now it's y over 4x. And we could multiply across the top and across the bottom. That would be fine. But it might be better, I think it's better, because we do have a binomial in here. X plus y is a binomial. I think it would be better to work on just canceling out, cross-canceling before we multiply. So I can see I have a monomial here with y. This is a monomial here. Each piece is individual, and so you can cancel out pieces of monomials, as you can see here. So this y can cancel out with this y here. That's a piece of a monomial. But we can't cancel pieces of binomials out. So like I can't cancel x with this x here, because this x is a part of this binomial. You can only cancel out binomials with matching binomials. And so on the top route we have the x plus y, and down below here we have a 7x times a 4x, which will give us a 28x squared. So that should be our answer. We should see that as our answer, x plus y over the 28x squared. And this one, because we did cancel the y out on the bottom, we do have to say that y can't equal 0. Obviously, we could see that x can't be 0 because x is at the bottom in our answer. Alright, so for number 7, this is kind of already in factored form. That's nice to already have done. We don't have to do any factoring. It's already done for us. So we're going to keep our first one the same here. So it's going to be x, and then x plus 1. This will all stay the same over x minus 2. But then I'm going to change division to the multiply, and I'm going to flip this one. So now the top will be what we have here, the x minus 6 and x minus 9. And then down below, this is going to be our numerator, will now become the denominator, x plus 1 and x minus 6. Now I'm just ready to cross cancel anything, any matching binomials, or if there's a monomial. We do have a monomial here, but there's no other monomials to cross out. So I couldn't just say I can cancel that x with this x, because this x is a part of the binomial x minus 2. So this is only going to cross out with another x minus 2. But we do have an x plus 1 and an x plus 1 down below here, so those can cross out. We do have an x minus 6 and an x minus 6 here, those can cross out. And so now we have an x times this x minus 9. I don't have to do a distributive property. I can just put x in front of that, and then at the bottom have the x minus 2. That's what we should see on our answer. So there's the x and the x minus 9 binomial, and then x minus 2 down below. And then we have to account for anything that we saw in here. Now here's where the division one has to go back even to the original problem. So you have to look at both of these now. So I see, okay, I have my x minus 2. I don't have to say anything about that. We know that 2 cannot be x. X can't be 2. We don't have to say that one because it's in the answer. But as we look back through here, we got to look at any other ones as well. So over here, this was a denominator here. It can't be 6. It can't be 9 either. So that one's from our original one. So there's the 6 and the 9. But now when we flipped it, it can't be negative 1 either. That's why we got to put a negative 1 in there also. And it also can't be 6, but we already have that one. So you got to make sure you go back to the original one with the division and look and see if there's any more from when you flipped it to put into what x cannot be. So you got to say x can't equal these three numbers. That is not apparent from the answer. We don't have to say 2. We can see that 2 is in the answer here. Alright, number 10, our last one. This one we will have to factor, so I'm going to have to go ahead and factor each one of these. So starting with, these are all going to be simple methods, so it's fine. Now you could, flip this one and then do all the factoring. I kind of do the factoring as I'm flipping it, just to make it a little shorter for me. So we have two. We're going to multiply this, two fractions, two big fractions here. So this is going to be just the way it is. So this will stay the way it is, but this one's going to end up being reversed, right? We're going to flip that one as we're multiplying. So the top here, we're going to see two binomials from the numerator. So they are going to start with x's. Two numbers that multiply to give me 15, that subtract to give me 2. That's a 5 times 3. They subtract to give us 2. They're different signs. The bigger one's positive. So positive 5, negative 3. Then below, two more binomials. Again, they both start with x's. Two numbers that multiply to give me 40. That subtract to give me 3. Well, that would be 8 times a 5. And that 8 times 5 does subtract to give us 3. They're different signs. The bigger one is negative. So 8's a negative and 5's a positive. Now over here, the top one here is actually going to be at the bottom. So we're going to put the bottom one first here. So our x squared plus 8x minus 9 is really now going to go to the bottom. So I'm going to put x's down. And now two numbers that multiply to give me 9, that subtract to give me 8. That's just 9 times 1. They are different. The bigger one's positive, so positive 9, negative 1. And now for this one, this numerator is now what the denominator was. So x and x here. Two numbers that multiply to give me 72, that subtract to give me 1. That's a 9 times 8. 9 times 8 is 72. And they subtract to give us 1. They are different signs. The bigger one is positive, so 8's negative. So now we're at the point where we can cross cancel any matching binomials. So I could definitely see x plus 5 I can cross cancel. I can cross out an x minus 8 with another x minus 8 there. The x plus 9's right above each other I can cross out. So I still have an x minus 3 on top and an x minus 1 on the bottom. Those do not cross out. So my answer should say that. But then I'm going to have to include anything that either from the original problem or from when I flipped it got crossed out, or if it was in the denominator here but then it got flipped to the numerator. So something like that. So if we look at this, if we go to this one, we could see we're going to have this in there. We don't have to say anything about 1. That's going to be in our denominator. But we do have to say all three of these for sure. Negative 9, negative 5, positive 8. Those three numbers, 8, negative 5, and negative 9, have to be in there. When we flipped this one, negative 8 or negative 9 and positive 8, I'm already still listing. So it looks like just the three numbers are the only ones. Yeah, negative 9, negative 5, and positive 8. Because if I flip it back to where we had it here, I'm still getting numbers that I'm already putting down. So I don't need to write them twice. Okay, so that concludes this lesson for 7.3. So you want to go on to the Big Ideas assignment, and I'll see you back in class.